VC Chemistry, Unit 4, functional groups that you don't need to name, but you do need to know the structures of these cyclohexane, benzene, primary amides, aldehyde, and ketones. Okay, so cycloalkanes. Well, namely, they are alkanes, so all saturated carbon-to-carbon single bonds, but they form a ring. Okay, so because they form a ring, therefore in their name it's prefixed by cyclo. Okay, but not cycle, but cyclo. Okay. Well, their molecules, they are cyclic molecules. Because of the extra carbon-carbon bond that close the ring, there are 2 less hydrogen atoms compared to a straight chain alkane. So if it's hexane, then it should be C6H14. But because you need that extra bond to close the ring, you have to lose that 2 extra hydrogen on each of the carbons. Therefore, the general formula for a cycloalkane resembles that of the alkenes because they lose 2 extra hydrogen, although there are no double bonds. Okay, so it will be CnH2n. So cyclohexane is C6H12. Carbons in a 6 carbons also form a very special ring that we name it benzene. Okay, so how is benzene different from cyclohexane? Now, each carbon in benzene ring has 1 normal single bond with their neighbors. They also have one normal covalent bond with 1 hydrogen, but the 4th electron on each of the 6 carbon, is delocalized around the ring. So they are actually shared among all 6 carbons, as if each one donate 1 carbon in the middle that forms kind of like a shared ring, a shared electron cloud structure. So instead of representing the benzene in this kind of way, although they are represented in this way initially, it is more accurate to use a circle inside the ring to represent the shared nature of the 6 delocalized electrons. Okay? So please do not imagine benzene as a 6 carbon ring with alternating double bonds. The 6 rings are in the middle, shared by all 6 carbons. They are not double bonds between these carbons. Therefore, these carbons are not, in terms of reactions, they are not really unsaturated. Therefore, it means that they cannot go through addition reactions to become cyclohexane. This is a very common misconception among students. Okay? Benzene rings are unsaturated, but they are not in the form of alternating double bonds. There are no double bonds in a benzene ring. Okay. Let's have a look between the cyclohexane and benzene. So cyclohexane is when 6 carbons are connected in the ring formation. It is very innocent. It's just a saturated hydrocarbon. Instead of being a chain, they're connected into a ring. Okay? And in high cyclohexane, each carbon is connected to 2 hydrogens. Okay? But in the case of benzene, 3 of the outer shell electrons form a normal covalent bond with each other, but that extra hydrogen. But the 4th electron is delocalized and shared among all 6 carbons. So although benzene is an unsaturated hydrocarbon, it cannot go through addition reaction to become cyclohexane. The carbonyl functional group. A carbon connected to an oxygen by a double bond. So all atoms are in a plane and the angles between bonds are 120 degrees. Which of the homologous groups that contain carbonyl group? We're not unfamiliar with it. Well, carboxylic acids and esters all have carbonyl groups in them. But we also need to know the structure of aldehyde and ketones. That is basically when the carbonyl group is by itself. Okay, so compared to alkanes, the molecules contain one carbonyl group, including carboxylic acids and esters. They will lose 2 hydrogen due to the carbon-oxygen double bond. Therefore, what will this do to the general formula? Compared to saturated straight-chain hydrocarbons, the ones that contains one carbonyl group will lose 2 extra hydrogens. Okay? Aldehydes. So the carbonyl group at the end of the chain connected to that extra hydrogen will form a aldehyde. So aldehydes all end in CHO. Okay, so if you have to write it in CHO in that particular order. Otherwise, people will think if you swap the H and O, people will think it's actually an hydroxyl group connected to a carbon. Okay, but when you write CHO, then people know it's an aldehyde functional group. Okay, so for example, aldehydes like methanol are not commonly used to preserve biological specimens. So why do we need to know aldehyde? Because aldehyde is the first stage oxidation product of a primary alcohols. Okay. So primary alcohols refers to the alcohol with a hydroxyl group at the end of the hydrocarbon chain. So for example, this primary alcohol using a very strong oxidant, acidified dichromate, then becomes an aldehyde initially. Okay, so when you further oxidize it, and then it will become carboxylic acid. So in organic reaction pathways, primary alcohols can become aldehyde and then become carboxylic acid. Okay? If the desired product is aldehyde, then we need to use milder conditions, so slightly lower temperature and shorter reaction time. So for example, a prop 1O primary alcohol being oxidized can become propanol. So the name, the suffix of aldehyde is Al. Okay? Although we don't need to know how to name it, but when we read the name, we need to know it refers to the aldehyde. Okay. Ketones. When the carbonyl group is at the middle of the chain, aka if we remove this hydrogen and replace it with another alkyl group, then we call this compound ketones. Okay. So ketones, for example, propanone, aka acetone, can be used as nail polisher remover, or we basically use it to dry clean, meaning wash and dry the cathode in electroplating. So the ketone is the oxidation product of secondary alcohols. So that's why we need to distinguish between primary, secondary, and tertiary alcohols. Because when the hydroxyl group is in the middle of the chain, that means the carbon only has one extra hydrogen connected to it. Under same condition, going through oxidation, it will only become ketones. And ketone is a rather stable compound. It does not normally further react with other compounds. Okay? So the oxidation for organic compounds can be interpreted as taking away hydrogen or adding oxygen. Okay? So sometimes we also use acidified permanganate as an oxidizing agent. Then how about tertiary alcohols? What do they become? Well, actually they become nothing. Tertiary alcohols cannot be further oxidized. Okay? We'll talk more about this in organic reactions. Then the last one is amide. So amide contain a carbonyl functional group, then attached to a amino functional group. So basically amino adding carbonyl groups becomes a primary amide. Why do we call it primary amide? That is when the nitrogen is connected to 2 other hydrogens. They are primary amides. If I swap any of these hydrogen for an alkyl group, then it becomes a secondary amide or tertiary amide when this nitrogen is occupied by 2 other carbons. Okay? The semi-structural formula for primary amide is a CO directly linked to a amino functional group.